Now, today we're going to have a look. Oh, excuse me, I'm going to sneeze. No, save it. Anyway, today we're going to have a look at exponential graphs. So I've got Desmos open to have a look at. And let's just have a look at an exponential graph. Now, actually, before we do that, I'm going to put y is equal to x to the power of 2 on there. Okay? X to the power of 2 should be familiar to a lot of you, which is a parabola. Nice. So what if I switch the 2 and the x around? All right, well, let's have a look and see what happens. Do you think we'll still end up with a parabola, or will we end up with something else? So we go y is equal to, and I put the 2 here now. And the big difference here is that x now is the power. So you probably haven't seen that before. So if I make x the power, whoops, well, there's some similarities, aren't there? But that left-hand side doesn't look anything like it. So we'll get rid of the parabola and we'll have a look at what's happening here with this exponential graph. Now it's called an exponential graph from the word exponent. So x there is the exponent or the index. So y is equal to 2x. You could describe that as an exponential equation or an index equation. And basically it's where the variable x in this case is a power, an index or an exponent. 3 words really that mean exactly the same thing. So it is different. Okay, we're not looking at a parabola, and therefore making x the index or the exponent has quite an effect on what that graph looks like. What if I try different numbers? Okay, let's have a look and see what happens here. So what if I go y equals 3 to the power of x? Okay, so if we look at this one here, it appears that that graph is steeper. All right, let's try another one. Let's go y is equal to 5 to the power of x. And that's steeper still. So increasing that number, or we call that the base. So increasing the base, the 2, the 3, and the 5, is going to increase the steepness of what's going on. So we can also do this kind of thing. I can go y is equal to 1.1 to the power of x. So we're not limited to just whole numbers. And you can see there, that's quite a different looking graph. It's nowhere near as steep. Now, all of these 4 curves that are up there are called growth curves. Okay, they're called growth curves because they're going up, and some more quickly than others. Okay, so an exponential graph can also be described as a growth curve. All right, now all of the numbers that we've chosen here, 2, 3, 5, and 1.1, are greater than 1. So what if I choose this one? What if I go y is equal to 0.5 or half to the power of x? And let's see what happens there. Right, so as soon as we dip below the 1, something different happens. It's like it flips. And whereas the steep bit used to be on the right, now we're finding the steep bit is sitting on the left. And if I change this number, come here, make that 0.9, you can see there that it's 0.7. You can see that kind of steepness occurs. So if the number is less than 1, it's no longer a growth curve. We call these curves of decay. So that should be something that you should notice, in that it's either a growth curve where it's going up as we move to the right, or it's a curve of decay and it's going down as we move to the right. And of course, if it's going down, then the base, the number that x is being raised to, is less than 1. The other thing to notice is that all of these graphs, including the decay curves, all pass through this point here, which is the point 0, x is 0, and y is equal to 1. So they all intersect y equals 1 on the x-axis. And in a minute, we'll have a look at why that is. We'll go ahead and we'll try and sketch one of these things. In fact, we'll do that now. And I'm just going to try and stop share and do a different share. So I don't know whether that's going to work or not. We'll give it a go. I'm going to try and switch to my iPad. Wait. Bear with me. It looks like it's working. Oh, okay, here we go. So let's go ahead and try and sketch. So let's say we've got the instruction and we've got sketch y equals 2 to the power of x. And we've already seen the shape that is, but it's worthwhile just investigating it as an equation and a table first. So I'm going to set up a table x, y. I'll put some numbers in there. So we'll start with 0, 1, 2, 3, and 4. And then we'll substitute those numbers into our equation y is equal to 2x. Oops, that's not what I meant to do. That one there. Y is equal to 2x. Okay, that one. Well, if x is 0, then what we're trying to work out here is actually 2 to the power of 0. Well, 2 to the power of 0 is equal to 1. In fact, anything to the power of 0 is 1. So we've got that there. And that's why, by the way, all of those graphs passed through y equals 1. Because it doesn't matter whether I've got 5 to the power of 0, 10 to the power of 0, negative 3 to the power of 0, they're all equal to 1, and that's why they pass through. Right, let's substitute 1 in there, so we get 2 to the power of 1. Well, 2 to the power of 1 is 2. 2 to the power of 2 is 4, right? So we've got 2 to the power of 2. Here we do 2 to the power of 3, 2 to the power of 4. And we're actually just doubling. So 2 to the power of 3 is 8. You can do that on your calculator, or if you happen to know your powers of 2, which you should, you can just fill those in. So we get 1, 2, 4, 8, and 16. Nice. Let's start and plot these points on a graph. So there we go. I've got an x-axis, a y-axis, and I think exponential graphs that look like red. They're going to be red. So let's start. We'll put 0. So x is 0 and y is 1. So we'll put that up there. We'll just count squares. So that's that one there. And square 1 is 2. We'll put that one in there. So that's maybe we just number these down here. Square 3, square 2, I'm up to, yes, is 4. So that's there. Just mark that as 4. That's 2. It must be 6, 8, etc. And the next one, well, next one is 8, because 2 to the power of 3 is 8. So when x is 3, y is 8. And the next one's 16. So I need to count another 1, 2, 3, 4, 5, 6, 7. It's actually up there. So it's off the screen. I didn't like that. It's gone and mucked around, but it's way off the screen. Let's look then, what about some negative values? Because we saw that there seemed to be sort of a tail to the left. So let's put some more values in and actually see what's going on. So let's add to that -1 and -2, and that'll give us some indication. Now, I suggest you use your calculator to work that out, but 2 to the power of -1 is a half. We'll just write that down as 0.5. Those of you familiar with your index work, you should know that 2 to the -1 is 1/2. Okay. And the next one there, 2 to the -2 is 1/4. But we'll write these down as 0.25 and 0.5. So we've got those values, and you can find those on your calculator easily enough. All right, well, we can plot those points. Let's go back to our red pen. So -1, -2. And they're getting quite small, aren't they? So that's a half, that's a quarter. And then the next one, if we keep going, because there's going to be an 1/8, it just will be. And we keep going, and it ends up, I've run out of x-axis there. Let's put some more x-axis in. Nice, there it is. And we can now join the dots, and we'll get a similar equation to what we had before. And there is y is equal to 2 to the power of x. And that's how we go about drawing them. And that's a table, that's an equation. So at year 11, what you are expected to know is the general shape. You should be able to do just what I've done from a table, sketch them, and be generally familiar and recognize the shape of the graph when you see it as an exponential curve. And I think that will do us for now.